Hello friends, welcome to GoodTecher LeetCode tutorial. Here this time we are going to solve combination sum coding problem. So given a set of a candidate's number C without duplicates and target number T, find all unique combinations in C where the candidate's number sums to T. The same repeat number may be chosen from C an unlimited number of times. So note here all numbers including target will be positive integers. The solution set must not contain duplicate combinations. For example, given a candidate set 2, 3, 6, 7 and target 7, a solution set is like this, array of integers 7, 2, 2, 3. So notice here they are like a number 2 is used an unlimited number of times. There are double 2's here, and also notice here there are no duplicate combinations. So like 2, 2, 3, if another combination 2, 3, 2, that's just the same combination. So we can only keep one in like this is 2, 2, 3 in ascending order. So look at this solution set structure. So like 7, 2, 2, 3, they are similar to the subset to this candidate set. So usually a subset coding problem is a typical coding problem to test the candidate's skills in depth-first search and recursion. So once you know how to use a depth-first search to solve the coding problem, it would be easy. So here, please just follow me. I'm going to demonstrate how to derive your algorithm to solve this coding problem. So suppose we have a candidate set like a 2, 6, 3, 7, and our goal is to find the target. That's 7. So this is our goal, to find the combinations to target. So all the combinations come from the candidate set. So the first step we are going to do is to sort this candidate set. Look at this, it's 2, 6, 3, 7. So I made this slightly different from the example in the LeetCode. So like this means that sometimes the candidate set is in random order. It doesn't necessarily to be ascending order. So first step we're going to do is to sort this to ascending order. So that would be 2, 3, 6, 7. So once we have this sorted array candidates list, we can do this depth first search. So I'm going to draw this depth first search tree to help you understand. So we start at the beginning. That's just an empty array. So at this point, our candidate set is just 2, 3, 6, 7, and the target is 7. So we do the depth first search. So we pick the first element, that's a 2. So that's a 2, and the index of this is a 0. So at this point, the remaining target is a 7 minus 2, that's a 5 at this point. So what we are going to do is keep going to do the depth first search. So we are going to do this one steeper. So this is 2 and 2. So the starting index is still from this one, 0, 0, because we can use the number in the candidate sets unlimited times. So we still from the first element. But here the remaining target would be 5 minus 2. So that's a 3. So we keep going, and that will be still from the first one, 0, 0 index here, and 3 minus 2. That's a remaining target is just 1. So if we keep going one step further, that would be 2, 2, 2, 2, 0, 0, index 0. And the target here, 1 minus 2, that's a minus 1. So minus 1 is less than 0. Less than 0 means this sum is already greater than the target 7. So that means this is not an eligible combination, and we should go in back. We cannot use this candidate. And we can totally skip this level. So we don't need to go to 2, 2, 2, 3. because we know if this one, the first one, because it's ascending order, you see why we're going to sort this array first. It's because this is sorted array. So if the first element 2 is already added to the combination, the sum would already greater than target. The next one, like 3, would be greater than target even more. So we can skip this level. So going back to this level, this is a finish, and we are going to back to this level, 2, 2. So 2, 2, from this 2, 2, we are going to, so the prefix is a 2, 2. So it's a 0, 0, 0. So this one would be 0, 0, 1. That's just the next one, 3 here. So we find this one. Luckily, the remaining target would be 0. So that means the sum is just equal to target 7. So that's one we need to record. So that's one we need to add to the final results. So this one we can add. This is a good combination we need to find. So like this step, we can going back, because here, like in ascending order, 2 to 3 is already equals to the target. So that means if we add like a next one, that's a 2 to 6, if a 2 to 7, they are also would be greater than the target. So we can skip this level because this one is already equal to the target. We don't need to do this level anymore. So we can keep going back to this level. So that's a 2. Start from the 0 index 2, and we are going to do this parallel. That's a 2, 0, 1. That's 2, 3 here. So 2, 3 here. That's a sum is 5, and the remaining target is 2. So we can still go in. So we're going to the 2, 3, because it's a first starting index is a 1. So 0, 1, 1. So 2, 3, 3. 2, 3, 3. We find this. The target is less than the 0. So the sum is greater than the target. So this is one we should not consider. So we keep going back and we skip this level. So no more like a 2, 3, 6, 2, 3, 7. So we can keep going back to here. So like here, we keep going to another way. So that's from the 0 index to the third one, 2, 6 index. So this one also, the target value would be less than the 0. So the sum is greater than target. So we don't need this one. So we also skip this one. So we don't need to have a 2, 7 search. So we can going back. So now we're back to this point and back to here. So we can start from the next element. So that's a 3 from here. 3 from here is a 1 index, and here the remaining target would be 4. So we go in. So that's a 3, 3. That's okay. So 3, 3, 1, 1, and the remaining target is 1. So keep going. So 3, 3, 3. So the target value would be negative 2. That's also too much for the combination. So we don't need this one and skip this level and keep going back and keep going back. So from here we do this one. That's a 3, 6. 3, 6 is also the target value would be negative 2. So this one we don't need to consider, and going back and skip the 3, 7. So start from 3 is finish, and going back. So going back to the next one, that's a 6. That's okay. The remaining target is 1. But if we keep going like a 6, 6, so index 2, 2 here. This one is too much for the combination. So stop this one and going back. So going to the last element. So last element, is 7. So 7 index is 3. So 7 is also just equal to the target value. The target value, remaining target is 0. So that's one we need to record. And in this way, because we don't need to search anymore, so we are going to back. So here we find all the combination that sum up to the target. That's 1, that's 2, 2, 3, and 7. So if you look at this whole picture, this is like a recursion way we are keep calling this find combination to target this goal. This goal is a problem started from the very beginning and to the each combination. Like every time we are constantly update the remaining target and also update the start index. So here we can build find the parameter we need for this goal, for this to convert this goal to a function that we can use for our coding. So what we are going to have, of course, is the first final results. So final result would be like this, array of integers. And second is a combination. So combination is like a reference that keep updating. So from the first empty array and then the add one of the element and add two elements. So this like a bracket is a combination. So and the next one, of course, is a candidate. So this is a candidates we have at the beginning. This is like a sorted array. We use this sorted array to as our candidate set. So all start from here, and the remaining target. So remaining target is keep changing. Like start from the 7, and when we add element, we based on this target, we minus this element value. It's keep changing. If we find the remaining target is 0, we will add this combination to the results. And the start index. So start index is keep changing. So start index is like a 0, 0, 0, 0, 0, 0. So if we find the start index, we are going to like repeatedly, because here like 2 we can use many times. So we start from the start index 0. The next time we still going to start from the starting index 0. And if this is a 1, we are going to start from the index 1. So okay, you know this, and then we can go back to the coding problem, and I'm going to demonstrate in Java to solve this coding problem. So as we see here, what we need to going to return is a list of integers. So we are going to call this as a results. So it's a new array list. And first we can do a edge case check. So if this candidate set is null, or if this candidate doesn't contain any elements, we are going to directly return this empty list of integers. And we just mentioned, our first step is going to sort this candidate set, because sometimes it's not ascending order, so we need to sort it to ascending order. So in Java, this is array.sort. So candidates will convert these candidates to ascending order. And here we are going to build our the combination set. So we will going to have a list of integer. Let's call it a combination. Like we mentioned here, it's a combination, just like this bracket is constantly refers to different combination. So we are going to have this combination. So it's also from an empty array list. And we are going to have a function. Let's call it to find combinations to target. That's a way one we just mentioned. We need to have these 5 parameters. So that's from results combination and candidates target and start index. So this is just a depth first search helper function, but I name this as to find combination to target because in the real industry, if you work with other people, you have to name the function with a purpose to clearly define what's the goal of your function, so other developers can understand what's the meaning of this function. So that's why I will prefer to choose a meaningful name for the function to find combination to target. So after that, this helper function will give us a combination, add all the combination to the results. So after that, we can return these results. So let's build this helper function. So let's call it private. So to find combinations to target, and we need to match these parameters. So first one is a list integer results and list of integer, that's a combination, and array of integers candidates and integer value target and integer value start index. So what we are going to do first here, so what's the terminal point? So that's if the target, as we just mentioned, this is remaining target. If the remaining target is equal to the 0, we are going to add the combination to this result. But here you will need to use a deep copy of this combination. Why we are going to have a deep copy of this combination? Because it's a reference to the combination. So like this combination will keep updating the reference every time. So if you finish all the diff first search, it will point back to the empty array. So you have to keep the value of the combination when the time the target value is equal to 0. So we can keep record the real value of that combination. And here we are going to directly return. So for its integer I start from the start index, we are going to increase this I. So like we mentioned, if the candidates is greater than target, so that's just a way to indicate that if this candidates, so like the time we see that if the candidate's value we added up, that we will get the less than 0 target, we will need to directly break this for loop, so we can skip this level and go back to the previous level. and we can, if we pass this criteria, so we are going to compilation.add, so add our current candidates to the compilation, and we are going to do this to find combinations to target, to calling this function at the next level. So we are going to results combination and the candidates, and the target here is just a remaining target, so target minus candidates I, and the start index is just the I. So because the next level, like we see here, we can still find the same element, so 2 2 2, so same element can be used at same time at many times. So here when we finish this level, when we go back, we need to go back to the previous level, so we need to remove the current level. So just remove the compilation size minus, so the last element of a current compilation. Okay, so that's pretty much all, and a quick check if there's a typo. So start from the results candidates. Now we edge case check, and return the results. We first sort this array, and we have a compilation. So compilation, we build this helper function, pass with the results compilation candidates target 0, and we do use this private function. If the target is 0, we add a deep copy of this compilation to the results and return. And if not, we doing this for loop, and they greater than the target, and we directly break, and we add this to find compilation. Okay, let's click the submit button. Okay, accepted. So very beautiful. We successfully solved this coding problem. So that's all about how to solve this coding problem. Hope you found this picture. You learn how to use a depth first search to solve this combination sum coding problem. So it's very interesting and a very common coding problem. So you can keep practice and learn practice well, and be more proficient to solve this coding problem. So thanks for watching, and thanks for subscription to GoodTecher YouTube channel. So let's keep making progress together. Okay, see you next time.